Good morning. In our previous video, we discussed about a relation in mathematics. Today, we will see what is a function in mathematics. In our previous relationship, definition of a relationship in mathematics, we have seen that a relation is a set of ordered pairs. For example, we have seen with ordered pair in fatherhood relationship, X is the father of Y, so X contains a set of all fathers and Y contains all set of all children of X. So X is a father and Y is the son or daughter of X. So here the first elements are called the domain and the second elements are called the range. It was discussed in our previous video. If you want to refer it, go back to the video and try to watch it. Today we are going to see about a function. What is a function in mathematics? Function in mathematics is a special relationship among the inputs and their outputs. So the inputs are called the domain and the outputs are called the range, members of the range. So let's take an example to elaborate the function. Let's take f of x is equal to x squared plus 3. So f of x can be represented by y. So y is equal to x squared plus 3. So f of x and y in mathematics we will use them interchangeably. So these are the inputs, and for these inputs, if you input the value of x in this equation, you will get the output. For example, 1 squared is 1 plus 3 is 4. As you can see here, when you input 2 in this one, 2 squared is 4, 4 plus 3 is 7. And if you input 3 in this equation, 3 squared is 9 plus 3 will be 12. And if you input 4 squared is 16 plus 3 is 19. So for each input, x 1 to 3, 4, you have an output for 7, 12 and 19 respectively. So most people in the area of research call the inputs as independent variable and the outputs as dependent variable. So x here is independent variable and y is the dependent variable. Function is also a set of ordered pairs. So a function is a set of all ordered pairs. It is then a relation. But not all relations are functions. Let's take an example. If you take the ordered pair 1, 2, 2, 3, 2, 4, and 6, 8, for inputs 2, we do have different values of an output. So for the same input, we should have exactly one output. So R is not a function. It is a relation, but it's not a function. So a relation R, to be called a function, it should satisfy this rule. For any ordered pairs x and y, and x and z is the same, y should be the same as z. That means for the same input, we should have the same values of an output. Y and z should be the same. In this case, we'll call R is a function. Let us determine whether the following relations are functions or not. Let's take a relation Rxy such that y squared is equal to x plus 3. Let's see this relationship whether it is a function or not. X squared plus x plus 3 is y squared is equal to x plus 3 is a function or not. To determine this one, let's rewrite this one as in a different way. Let's see, let's take the square root of both sides. So here y squared, square root is y. So the y value here is plus or minus square root of x plus 3. Therefore, y should have two values, the plus or minus of this one, the square root of this one. So for a single value of y, x, you should have different values of y. Here you have different values. Let's say, for example, 1 for x. X plus 1 is 4, x plus 3 is 4, square root of 4 is 2. The y value for x is equal to 1 will be plus or minus 2. So for a single value of x, for a single input, you have different values of y, 2n minus 2. So for any values of x, you have a plus and minus value. So this is no more a function. What about this one? This can be rewritten as y is equal to x minus 3. Y is equal to x squared minus 3. So for any values of x here, y have a single value. Should have a single value. It will not be repeated. So this is a function. What about this one? Absolute value of x plus 1. Y is equal to absolute value of x plus 1. So whatever x values you substitute here, you have only one value of y. So this is also a relation. What about domain and range? Domain and range, range is also called codomain. As I said, f of x and y. So y is equal to x squared plus 2x plus 3 means f of x y and f of x are similar. So what is the domain of this function? The domain should be defined for all values of r, but here x should be different from 0. If it is 0, the value will be undefined. So the domain of this one will be all real numbers except 0. What about this one? B, 6 plus square root of x minus 4. This means x, 2x minus 4 should always be greater than or equal to 0, because the square root of any number should be positive. Inside the square root expression, this should be positive. So 2x minus 4 is always greater than or equal to 0. That means when you equate this one, 2x minus 4 is greater than or equal to 0. 2x is greater than or equal to 4. X is greater than or equal to 2. If you divide both sides by if you divide both sides by 2, you will get x is greater than or equal to 2. So the domain here should be greater than or equal to 2. That means the domain should be x such that x is greater than or equal to 2. This expression is always greater than or equal to 0. So 6 plus any number greater than or equal to 6 is greater than 6. So the y value is always greater than or equal to 6, as this one is always greater than or equal to 0. So we can say that the range is y such that y is greater than or equal to 6. Determine the domain and range of this equation. This will be an exercise. Please write your answers on the comment section. Thank you for attending.